Hey, Algebra 1, we are moving on to inequalities. Inequalities we're going to solve the same way as equations, so we're still using reverse PEMDAS when we get there. I kind of made a cheat sheet for you guys with the signs, how you read it, and then graphing it. And graphing is just plotting it on a number line this time. So we're going to pretend that like the x's or the variables, the y's are on the left sides of all these signs, and then the answers would be on the right, okay? So this sign with the gator eating the x would be x is greater than the number, so we read it as greater than. And since we're just greater than, we're going to put an open circle at the number, and then all the numbers greater than that number show up to the right on a number line. Less than, the gator is eating the number, not the variable. So like x is less than 3. If 3 is right here, we put an open circle, and numbers less than 3 are to the left. Greater than or equal to, this line underneath means or equal to. So x is greater than or equal to like 2. If 2 was right here, we'd put a closed circle this time because we can be equal to. And then the arrow's pointing to the right. And then less than or equal to, right here in the blue, we got like x is less than or equal to negative 5. If negative 5 is right here, it'd be a closed circle, and numbers less than negative 5 would be going to the left. So the way that I think about the circles, let's say that you're walking on a road, and like there's numbers on the road. So if x is greater than or equal to 3, and 3 is on the road right here, since you could be equal to 3, you could step on this part of the road, right? You wouldn't fall through. Whereas if you have like x is greater than 3 and 3 shows up on the road right here, you can't be equal to 3. You can't step on 3. So if you stepped in this open hole, you'd fall through. So we can't step on that part of the road. Maybe that makes sense. Maybe it doesn't. I hope it does. But if not, let me know and I can try to think of something else. So here we have an example. We're going to solve this exactly the same as if this was an equal sign right here. So reverse PEMDAS, we're doing addition and subtraction first. Let's get rid of the minus 4 with adding 4 on both sides. Now we have 3x is greater than 9. The imaginary times sign right here, let's divide by 3 and cancel it. So x is greater than 3. Notice there's no line underneath, so we have an open circle. Refer back to your graph, and the numbers greater than 3 are to the right of 3. Here we have 2/3 y plus 1 is less than or equal to negative 3. Let's get rid of the addition and subtraction. So opposite of plus 1 is minus 1 on both sides. So now we have 2/3 y is less than or equal to negative 4. Negative 3 minus 1 is negative 4. We don't like fractions, so how do we get rid of a fraction? We multiply by its reciprocal, or we just like flip the fraction. So we had 2/3 here. We're going to multiply by 3 halves, just 3 on top, 2 on bottom. Now these are all going to cancel, but we got to do it to both sides too. So negative 4 times 3 is negative 12, and we have a 2 on the bottom. Well, negative 12 divided by 2 is negative 6. So we have y is less than or equal to negative 6. Since there's a line underneath, we can be equal to negative 6, so we can step on that part of the road, and then less than numbers are to the left. Last example, we got parentheses here. So we're going to distribute in just like normal. So now we have negative 7w minus 28 plus 8 is less than negative 83. We have like terms here on the same side of the inequality. So like just like the same side of the equal sign, we can combine like terms. So now we have negative 7w minus 20 is less than negative 83. Reverse PEMDAS, let's get that 20 over. So we're going to add 20, and then we're going to divide by negative 7 to get w by itself. Remember, there's an imaginary multiplication sign right here. Now, key is when we divide by a negative with inequalities, we have to flip the inequality. So these negative 7s cancel, and instead of w is less than, now we have w is greater than. So we flip that inequality. A negative divided by a negative is a positive. 63 divided by 7 is, holy cow, it is 9. I apologize. That should be a 9 right there. Oof. So again, we should plot with a 9. You always got to have a 0 on your plot. That should be a 9. Open circle because there's no line underneath, and then numbers greater than 9, not 8. Numbers greater than 9 are to the right.